Now, before I show this off working, I thought I'd give a little bit of an introduction to this. So, I've been building robots for coming up to 10 years in November, and in that time span, I've never built a walker, so I thought I'd just take the opportunity to mark it before I reach the milestone, and have a go at making one myself. So this is just currently the prototype. It's just on a little test base. It will be a spinner. But to give some examples of what I've done, I've just basically created some legs on a camshaft, and I'll show what it looks like spread out on SketchUp here. And I did a lot of super gluing and just inserted the legs in between into the centres. And yeah, this is what I have ended up with. So it's 4 legs per side. There's a bolt there to hold the top of the legs in place, otherwise they'll just end up spinning around. Currently running on some, I think they're 2000 RPM N20 gear motors. The receiver is temporary, because I will get a pinless one hooked up and there won't be any of this wiring. The battery may need to change, as this one might not fit in. But other than that, I'm surprised at how well this thing works. I'll just give a little demonstration of the legs running before I put it on the testing base, and then I will show what else I will be doing with this. One issue I'm currently having with this is the direction control. So forwards and backwards to that is fine, but it slides to the left. But left and right, I have to go left to go right and right to go left. So I need to change the polarity on the motors when it goes into the final Antweight. But it works. I mean, the legs are getting a bit jammed, but... and I'm constantly going in the left direction, but... Right, so I've taken the wheels off one of my previous Antweights just to show how well this thing can push. So the thing weighs, I think, somewhere between 120 to 130 grams without the wheels. But... okay, well that didn't go to plan. Try that one more time. Third time's a charm. Okay, the legs on one side keeps constantly getting jammed. I think that's the thickness of the rubber bands being used as traction to have something to do with it, but also notice there's not so much weight on it, but when it's a full walker, when it's a full machine, it should be able to push a lot better than this. Well, let's see how well it pushes Super Nintendo Chalmers, which is around 151 grams. So... not well at all by the looks of it. Alright, so I've taken off one of the legs, and I'll explain why I've done this in a little bit, but just to show, I'll zoom in a little bit so you can see it a bit better. But you can see that there's 4 legs on there, and they are 1 millimetre thick, so they're probably not going to hold up well for combat. And as you can probably see, if my camera can focus, At least it should be able to. Now, these are 1mm thick, and yeah, that'll do. So you can probably see that they're not going to hold up well if it takes on a horizontal spinner. They are quite thin and flimsy. So what I've done is I've replaced that with this version, and what I've done, there's 3 legs on here, but they're 2mm thick, so double the thickness. They are a little bit longer on the, well, leg base, but hopefully they should hold up a little bit well, even better than that one, and they shouldn't be as flexible as the other ones. So, because of the amount of spacings between them as well, the rubber band, which is being used for the tyres, shouldn't get caught up in them, so let's give this a shot. Actually, before I do that, I thought I'd show it all laid out in pieces so you know how I fit it together. So I take this first bit and then I put it on the motor shaft. So now that I've got it on the motor shaft, I take one of the legs, just basically place it on the circular area, and it's fallen off, so I can't really... God, I can't even do this. Sorry about that. So what I've done is I've just taken one of the legs, put it on the other bit of the motor, then I apply a bit of super glue around this area, then I repeat the process until I get to the final bit here. So yeah, that's pretty much it really. Alright, so there's not as many legs as before, but they are double the thickness, and I've not put any rubber on them just to see how they run. Let's give this a shot. Okay, I have given the battery a full charge because it was getting a bit weak and the drive motors weren't holding up. And also, I've not put any rubber on the feet yet, but I might do that later on depending on how well this performs, but... Okay, I'm definitely going to want to put... The other thing I might want to do is put a lower RPM version of the motor in, because these ones don't have a lot of torque and they're more speed focused rather than... It's just... Okay. So what I've done here is I've done the same process like I did before, just basically took a rubber band, cut it up, cut the bits in half, and then super glued them onto the bottom of the legs, and also did the same on that side as well. Okay, problem with the jamming on one side aside, this is so much better, and okay, so first push test with the new legs is this gearbox, this planetary gearbox, which is probably around 200 grams. So guess not. Right, so the reason why pushing isn't so well, because this is probably around 60 grams, given the weight of all the components and everything, and the fact that it's not an entire Antweight, but this should be at least 225 grams, so it'll be a lot heavier than that in comparison, but I don't know if it will push it, but no, it doesn't want to happen. Let's just try. Oh, and the legs are jammed on one side. And they dropped the transmitter because I'm stupid, and it's... let's try that. Oh, that's forward. Backwards. Okay, you know what? It's not going to happen. So the next time you see this thing, it will be a proper Antweight. We'll have a spinner on it, but that's all you're going to see of it for now.